5 7 7 8 8 10. Okay, so the array value is basically, suppose 5 7 7 8 8 10. So what I'll do that, and the value is basically 8, suppose. So what I'll do that, first basically I'll take that lower bound of that value and the upper bound of that value. So what the value, if I've been taking the lower bound, what I'll do that, lower bound, it means that it will be lesser than or equals to. So what is that? That the 8 values be 0 1 2 3 4 5. So 3 will be the answer, lower bound, if I've been taking that. So 3, and upper bound is which is strictly greater than that value, strictly greater than that value. So what I'll do that, that is the 10. So that the values will be 5. So I will return the 5 minus 1, that is the 4 in that case. So I'll have to check another condition. Basically the upper bound is basically also the binary search technique has been there. So that is why this library function or the lower bound or upper bound, it will take that order of log n time complexity. So what is to do that? First I will check that if the lower bound is into the end, that means that is not possible to present that value. If the lower bound, that is the value, if the lower bound is equals to that array dot end, or the lower bound not equals to the that means the target. Basically lower bound that is not the target, that means that if the lower bound has not been exist, that means suppose that 8 has not been present, so that is why the 7 will be that, suppose that is the 9999 has been present. So if I've been taking that the lower bound of 8, what will be that the lower bound will be the value will be 7. So the LB is equals to not equals to the basically the target. In that case I will directly return the -1 because that is not possible. Impossible case I will checking there, and otherwise I'll do that. What I'll do that the lower bound value minus the array.begin value. So that is why that what I'll do, return that will return the index, that will the index. And if I have been written the upper bound -1, then the array minus begin, what will return that is the ending of that last value. So that after that I will return that as a lower LB and the UB as an answer, LV and UB. So basically if I have been taking that the time complexity is the order of log n, and I am not taking any extra space, but that's the two value vector I have been taking there. So that is the order of constant space basically. So space complexity is equals to order of 1. So right now I am trying to implement my logic as a coding interpretation. So what is that? Vector of integer of -1, and then will be lower bound nums dot begin nums dot end, and that value, the target. So upper bound is equals to nums dot begin nums dot end, and the target. If lower bound is equals to array nums dot end, or star LB, that means that the value of that lower bound not equals to the target, that is mean that is not present there. So it will return the index, that means -1 and -1, and otherwise the index of 0 will equals to lower bound minus nums dot begin, and index 1 is equals to upper bound minus 1 minus nums dot begin, and after that it will return the index. So let me check that if my approach is right or wrong. Okay, it's giving me an compile time issue. Okay, nums dot begin, nums dot end. Okay, so spell mistake. Yeah, it's giving me an accepted solution in run code. I'm trying to submit there. Yeah, it's got accepted. Thank you so much.